Hello everyone. We'll today look at formatting output. So formatting output. So we have declared our x equal to 5. Then run this command. Then we print this. This is the basic or default format that print statement gives us. So if you want to do something different, then we can do like this. For only, let's say, price point to F, then dollars. Run this. Now if I print txt, so it gives something like this, but instead of, and we can put a variable inside whatever this curly brace is. So let's say print txt dot format. Now here our variable inside this is price, so we'll declare price equal to, let's say, 4.25. Now let's print this. So instead of point to F, we got the value of this price. So price equal to point to F and price equal to what we declared is 4.25. So we get for only $4.25. So we can format or gives value to whatever inside this variable inside this curly braces. Let's look at another example. So let's say text dot format. For this time we say price equal to, let's say, something with 2565. So instead of printing 2565, it prints 2.6. So why is that? Let's try altering this text here. Control A, Control C, and put a value 3 instead of 2. We run this command and now format this text. Format price equal to, let's say again, 4.2565. So what do you think it will print now? So now it prints 4.256. So what we see here, this point F or 0.3F means how many digits after the decimal number it will print. Normally it rounds off after that. So here it is 2, 5 and then 6. So it rounds to 5 to 6. And here it is 5 after 6. So it normally rounds is to 256. So 0.3F means basically how many digits do you want to display after the decimal point. Let's look at other example of the formatting. So we have text1, which is equal to my name is something. Here f name is actually a variable, and I am something. Here again is another variable. And now after this statement, let's run this. If we print txt1 this time, it will just print whatever there is, but we can format this text1 dot format And now we can pass the variables. So let's say for f name we can pass Hira, and for age we can pass 25. And now it will print hmm, oh, so we have to declare text1 dot format. So we have f name equal to, let's say, Hira, and age equal to 35. Now print this. So now instead of this f name inside the curly braces, it will print Hira, and instead of 35 or age, it will print age equal to 35. So it's 35. We can also print this in another way. Let's say number indices. Here, instead of giving f name or any variable or age or any variable, we can just put the indices. For example, let's say text2 which will be my name again. My name is something. Let's say its position is 0, and I am something years old. So let's print text2 this time. So it prints whatever we give it. Now we want to format this. So now we do not have to give any variable such as f name or age. We can simply write Hira and 35. And print it. Okay, for number indices, we can put 0 and 1 or 2 or anything instead of these variables such as f name and age. So txt2, if you print this, we'll get this. Now if you want to format this, text2 dot format. So let's say Hira and 35. Hopefully this works. So here the format, the position of Hira is 0 and position of 35 is 1. So the 0, anything in this position will be put here, and it will put anything at this position at here. If it swap, we can swap this as well. Let's say we have text3. I am something years old. Let's say 1. And my name is something. Let's say 0. And we can format this text3. So it will print as it is. So if you want to format this, text3 dot format. So let's repeat this same thing. Hira at the first position and 35 at the second position. That it is Hira at 0th index and 35 at first index. So it will put this 35 which has first index in this position, and Hira which has 0 index in this position. So that's formatting, and we can do this without putting anything, that is using empty placeholders. Let's say text for my name is something and I am something years old. So text form, let's print it. Now try to format things. Format, let's again use the same variables. Hira and 35. So my name is Hira and I'm 35 years old. So whatever it does something automatically. Whatever the value we give here in 0th index will be printed here at its 0th position or first position, and 35 will be sent here. So now let's try mixing. Text 5 equal to, let's say my name is, we put a variable here, f name, and I am, let's say it's 1. No error so far. xt5, let's print it as usual. So let's try formatting. Format, again pass the same string, Hira, and the value 35. Will it work? It will generate error. So mixing doesn't work. You have to either put variable inside both place or number inside both place or make them empty. So does this work? My name is f name and with empty placeholders, it will not work either. Neither will this one work. Or let's say it's 1. Fine. So we can use name with the placeholders, value with the placeholders, and empty placeholders, but we cannot mix them. So now let's see another things. We can use this symbol to left align the value and so let's say we have text. We right, dogs, and let's print it. Txt dot format and put some value inside it. So let's say 12. What will this do? We have 12 dogs, so there are 8 spaces after 12, so 12 is aligned to left. So what will happen if you do the opposite? Let's say this will help us to right align. Right, use right here or less than symbol, and now let's print it. Oops. we have 12. So we can see the difference. 12 is left aligned in this case and 12 is right aligned in this case. So what should we do when we have to align things in center, or that 12 in center? So we'll use this symbol and here. So now there are 12 is in middle, so that is something, it have 4 spaces in left and 4 in right. So that's another kind of formatting. So again, we have used in the first example percentage f to print a floating point number. So let's see another example of percentage f, and what do we do when we need to print integer values. So let's say we need to print a number. Number 1 is something, that is percentage D. Number 2 is another thing, that is percentage F. And let's percentage, and then let's say we have the value of the number 1 is 1 and value of number 2 is 3.1415. What will happen? So instead of percentage D, it prints an integer value, and instead of percentage F, it prints a floating point value. Let's twist things a little bit. What will happen if we put percentage F here and percentage D here? So since it takes 1 as a floating point number, it adds multiple zeros after decimal. So now this number will be considered as floating point, and in second place we are printing the integer number. So it will convert this to integer value, that will only this 3, and print it. Okay, let's see other examples. Print, we have our number. Let's put point to F. So what is work of point to? As we have already seen, let's say 3.14151632 is our number. So what will this print? So percentage 2 will only print 2 digit after decimal, and if there's percentage 5, then it will print 5 digit after decimal, 3.14152. Okay, so we can also put a number before this decimal point. So let's see what will happen then. Let's say it's 1.2 instead of 0.5. So we don't see too much changes, but let's say it's 5. So we didn't see the number. Number is somewhere here. That is, it puts 555 spaces before printing this 3, or before this decimal point. So here in negative 555, then you will see this decimal, or this is in the position of the 554th position, or last position. So to make things little clear, let's print multiple of those so we can get a clear value. Print number, let's say our number is 0.2f, percentage 5.333. Let's print another number, another number, and another number. Let's say its value is 5, its value is 5, and a large number. So what this will basically do? So no too much difference. We can see only all numbers are printed before decimal as they were, and after decimal point only 2 digits are taken. So it's clear that what happens when there is a 2 or any number after the decimal point here. Let's to make things clearer, we put 5 here, 5 here, 5 here, and 5 here. Now we'll see what will happen. So now difference from here to here, there are 5 spaces. So that is the reason why that 5 is shifted. We don't see that shift here. So there is always a 5 spaces or 5 empty spaces before this decimal. So in this case there is 5, 3 is occupied by this, and 2 here. Again same case, and at least there is 5 spaces. What we increase that 5 to 15 or something. Let's say 15. Let's say 15. Let's make it 15. Let's make it 15 and run it. Now we can see a clear difference. So from here to here there is 15 gaps or 15 spaces. One of them is occupied by this 5. From here to here there is also 15. 3 of them is occupied, and so on. So we can use the number before to make or decide how many spaces do you need, and number after this decimal to decide how many numbers after the decimal point we want to print. So now let's look at printing the octal and the hexadecimal values. Print. For octal we use percentage %O instead of percentage %D. So percentage %O, and let's take it here. Let's simply 10. So what will it give? So it is 12. Why is it 12? Let's print another value. Percentage %O, percentage, let's another number, that is 25. So this gives 12, this gives 31. So why is that case? So now let's deal with the octal number. So how do we print octal number with the print statement? So octal number, we use percentage %O, then percentage, and the decimal number. Let's say we have a decimal number 10. So it's 12. Why is it 12? Because 12, 1 into 8 plus 2 equal to 10. So 12 is the octal conversion of the decimal number 10. So let's look at another example. Let's say we want to convert 25 decimal 25 into octal. So what will you get? 31. Why is that? Because 3 into 8 plus 1 equal to 24 plus 1, that is 25. Or if you want to convert 25 directly to its octal, you divide it by 8, you get a number, that is you get 1. Then what comes out of division is when you divide 24 by 8, it's 3. So that 3 and 1, those are remainder. So let's try it. Print percentage O, percentage, let's say 25. So it seems that the big O is not supported, so we'll come back to small o. Again is 31. So now we'll look at hexadecimal number. So before we have seen that to print hexadecimal we have used X, or to represent hexadecimal number we have used X. So similar in this case, here we'll give X instead of O. X percentage, let's put 10 again. So what's equivalent of 10? It's A. So in generally what happens in hexadecimal, there are 0 to 15. They are represented by 0 is represented by 0, while 10 is represented by A in hexadecimal, 11 is represented by B in hexadecimal, and so on. Similarly, 15 is represented by F in hexadecimal, and after that 16 is represented by 1 and 0. So let's try to print 16. So that is percentage X. Again, if you want to try capital X, we can try. But so let's say we want to convert decimal of 16 to hexadecimal. So in this case, X works, capital X, while in this case, capital O generates an error. So we can also see the 16 of decimal. When you convert hexadecimal 16 to its hexadecimal, we get 10. Let's print percentage X, percentage, let's say 14. So since value of A is 10, 11 is B, 12 will be C, 13 will be D, and 14 will be E. So that octal and hexadecimal for you. And we can also print exponential numbers. Print, let's say percentage, and then point, we'll simply put E here, and then try to print this one. Let's say 23.56. So it will basically move the decimal to left, so that there is only a single number to right, or sorry, to left of the decimal, and all other numbers are on the right of the decimal. And since it has moved a decimal to left, it has added a power of 1. So let's print a little bit bigger number. Let's say 233.566. So what will this yield? It again moved this decimal to 2 places to left, so that there is only a single digit on the left of the decimal and all other digits are right. Since it has moved it to 2 places, there is a power of 2. We can look at other examples where we can limit number of numbers after the decimal, as in the floating point case. That is, if we put 0.3 there, So only three numbers after decimal will be printed. So this decimal point will be moved here, and the three number after that point will be 3, 3, and 5. So since 5 comes before 6 or 6 comes after 5, whatever you say, it is rounded off to 6. So 566 is rounded off to 6. So what we get here is 2.336 10 to the power 2. Apart from that, we can also use tabs and spaces or new line here. So let's say my name is Abdul, and let's say this will generate a tab from. So what will happen if we do it without the tab? No tab here. Now you see the difference. What will happen, instead of backslash t, we use backslash n. So my name is Abdul, and due to this backslash n, the new line is created, and the rest of the text is printed in the new line. So far we have seen formatting output. And in formatting output, at first we look at the formatting output with this curly braces, and then printing numbers in form of %d and %f. Also we looked at the left align, center align, and right align in the middle. And then we looked at the printing octal numbers, hexadecimal numbers, where the conversion is drawn inside the print statement. And also we looked at exponential number, and finally this tab, which causes spaces of and new line that is done by percentage \n. After this topic, we'll look at random numbers. The module for random numbers, we need to import a module, and to import module we need to type the command import module. So random, let's say random. Okay, so this is the first module that we have introduced so far. So random module is inbuilt in Python. We don't need to install it from using pip or any other command. So what does it do? So let's say random, random, random. So I'll run this. So it will be basically generating a random number. For this case, it generated 0.24. This might be different in this case. To make random not so random, or to be sure that whatever I run here will be duplicated in your case, we can use the random seed. Let's say seed of 5. Now again we run the command random. It's 0.6229. The same will be in cases if you replicate this command. To generate a random integer instead of these real numbers, we can use random int. This is the start from where we want to start, and this is the stop, the final number of the maximum number. So instead of start or stop, we can also write this minimum integer that we want, or the maximum integer that we want. Okay. So let's generate some random number. So random and int. Let's say minimum value is 1 and maximum value is 10. Now, so it gives us 6. We can also generate a range of negative to positive numbers. So random minus 100 to 100, it will generate 76. The range can be also from negative to negative. Minus 100 the minimum, the minus 90 maximum, and it will generate minus 90. There is something called list that we'll learn in the later chapter, but we can also create a random number or generate a random elements from a list. Let's say we have a list 1, 2, 3, 5, 6, 8, and from list we can generate a random value. So when you run this code, you might get the same result as which is due to this seed value. If you change the seed value, you might get a different result. So at the end, we'll look at the this. What is this? Or put it here. So, and I don't think this is funny or whatever you call this. So this is some sort of rules or guidelines that is beautiful is better than ugly, explicit is better than beautiful, simple is better than complex, and so on. By Tim Peters, I think. So that's it for this first chapter. See you in next chapter. Thank you.